Exercise 22B, page 220.
Now, as every school pupil can tell you, as long as an object is above the last traces of Earth's atmosphere, it will stay in orbit for thousands or even millions of years. Eventually, a month or a millennium after launch, it will hit one of the millions of other objects orbiting the Earth. That collision will generate new fragments that will go whirling around the planet until they too are involved in collisions. Over time, everything in Earth's orbit will be ground into celestial scrap. So, what do we know about the problem of space junk? Well, venturing into space is inherently risky, and orbital debris is just one of the many hazards that a space traveler faces. But the debris hazard is unique in being a product of our own environmental negligence. After a mere 40 years in space, we have seriously polluted the final frontier. Valuable orbits are peppered with debris that threatens the operation of satellites and the lives of astronauts. A small group of orbital debris experts have been concerned about this problem for years and have slowly gained the attention of the government agencies and commercial enterprises that are now leading the way into space. Yet every 4 days, on average, another rocket will be launched into space, making the problem worse. Space may seem remote, but it's really not that far away. If you could drive your car straight up in just a few hours, you'd reach the altitude at which the space shuttle flies. The popular orbits for satellites begin twice as far up, about 400 miles above our heads. Since 1957, there have been over 4,000 space launches. The leftovers from these launches, used-up satellites, the rockets that carried these satellites aloft, equipment from aborted scientific experiments form a sort of orbital time capsule, a mausoleum of space technology. In 1963, 400 million tiny antennas about the size of needles were released into orbit in order to see if radio waves would bounce off them. Communication satellites soon made the antennas obsolete, but they still float in lethal clumps 1,500 miles overhead. In 1965, the astronaut Michael Collins lost his grip on a camera while on a spacewalk. Many spacecraft shed debris, bolts, lens caps, equipment covers, the way children shed toys. Even the paint on spacecraft has a tendency to erode in the harsh environment of space, creating a cosmic grit that now pelts everything in orbit. Many of the objects released into space, like Collins's camera, have fallen back to Earth. The upper atmosphere, where the space shuttle flies, gradually slows objects down. They re-enter the atmosphere and burn up within a few months or even years. But a few hundred miles higher, the atmosphere is so thin that it is ineffective for cleanup. Spacecraft that are launched into orbits at this height will stay in space indefinitely. Especially troublesome are pieces of the more than 100 rockets and satellites that have exploded in orbit. At the end of their useful lives, spacecraft typically contain some fuel left over from the launch. The fuel tanks deteriorate over time and are punctured by debris. The leftover fuels mix together and explode. In the worst case on record, the explosion of a European Ariane rocket produced more than 500 pieces of debris big enough to disable a spacecraft. Eventually, the number of explosions will diminish, but by then spacecraft will be breaking up for another reason. As more objects go into orbit, spacecraft will begin colliding with and being shattered by debris. Furthermore, collisions beget more collisions in a process known as collisional cascading. Once cascading begins, the number of objects in a particular orbit will gradually increase, and the risk to satellites and manned spacecraft will rise accordingly. A team of researchers in Italy have calculated that enough objects are already present in 2 popular orbits for cascading to begin. By the time the cascades have run their course, in 100 years or so, even small spacecraft will suffer damaging collisions after just a few years in orbit. Human societies have done plenty of things that we, or our descendants, may someday regret. At the beginning of the atomic age, we seriously polluted vast tracts of land that will take years to clean up. We have increased the amount of carbon dioxide in the atmosphere despite a scientific consensus that global temperatures are rising as a result. In 1987, the World Commission on Environment and Development defined sustainable development as meeting the needs of the present generation without compromising the ability of future generations to meet their needs. In space, we are failing the sustainability test miserably. 100 years from now, when our descendants want to put satellites into orbits teeming with debris, they will wonder what we could have been thinking. The simple answer is that we weren't thinking at all.